Hey YouTube, I'm Sergeant Indy. Welcome back to my turn-based strategy tutorial for GameMaker Studio. This video, we're going to be coding the foundation of our cursor object, but first, as promised, we're going to go ahead and do the diagonal neighbors. So let's go to our OGame object and right into its create event, and then right here at the bottom, we're just going to keep going. So top left neighbor, and then if XX is greater than 0 and YY is greater than 0. And DS list add node.neighbors map XX minus 1 YY minus 1. Great. Except we need a parentheses. Before I go on any further, some people have complained that wherever they're at, they're missing certain symbols on their keyboard. So if you ever see me type this is an AND. Know that AND is a keyword. If you see me type one of these, that's an OR. OR is a keyword. And I don't know what the symbol for XOR is, and I never use XOR really, but XOR is also a keyword if it ever does come up. So, if you ever see me type any of that, don't panic. There are keywords. So, top right neighbor. If XX is less than map width minus 1 and YY is greater than 0, DS list add node.neighbors map XX plus 1 YY minus 1. Great. And I should scroll down a bit to try to keep this all that I'm working on kind of in the middle of the screen. So bottom left neighbor, if XX is greater than 0 and YY is less than map height minus 1, DS list add node.neighbors map XX plus 1 YY. That's wrong. Plus 1. That's wrong already. That's all. This is a minus 1. What am I doing? So XX minus 1, YY plus 1. Great. And then bottom right neighbor. If XX is less than map width minus 1 and YY minus map height minus 1. DS, come on, list add node.neighbors map XX plus 1 YY plus 1. So quick check, everywhere we've got a minus 1, well, first off, everywhere we've got an X, it's width, and a Y, it's height. So let's do that real quick, just a quick visual check. So Y and height, X and width, and these are both right, great. Everywhere we've got a minus 1, we need a plus 1 in here. So minus 1, plus 1, plus 1, minus 1, plus 1, and obviously otherwise it's a minus 1. So minus 1, plus 1, minus 1, and great. This all looks fine. Awesome. I'm going to leave this whole thing up for just a minute. If you're falling behind or if you think you made any mistakes, go ahead and pause it now. Double check. And let's green check all the way out. And let's run it, because we can test this one right off the bat. Okay, great. So, looks great to me. What you're checking for is all of these ones in the middle, in the meat here. They should have 8 neighbors. That's 1, 2, 3, 4, 5, 6, 7, 8. These guys along the side should have 5, like this guy. 1, 2, 3, 4, 5. And the ones in the corner should have 3, because 1, 2, 3. So, check all your corners, check all your sides, and if what you're looking at is what I'm looking at, great. If not, go ahead and go back and try to find out where you went wrong. Let's X out of here, and now we need to do some cursor and mouse stuff. So, first we'll need a new sprite. I'm going to call it sCursor. sCursor. Edit sprite, new sprite, 32 by 32 is just fine. What we want is a nice bright red color. And get our line tool. And we just want like 4 lines going down here. We want this thing to be super easy to see. And then we want to go diagonal corner to corner and just fill this out until you think it looks good, really. This line still looks a little scrawny to me, so I'm going to do a couple more. All right, so that's it for me. I think that's good enough. Awesome. Green check out of here. And we're not done here yet. What we're going to do is we're going to copy that image, and we're going to paste it. So we got a total of 4 images, and we're just going to leave them all exactly the same, just like that. You'll understand why in just a minute, but green check out of here. And we're not done here. Our origin 0, 0, that's perfect. We just want it to be the very top left corner of this sprite. Great. But our mask is wrong. So let's modify the mask. Manual. And we only want the very top left pixel to count for this cursor object when it goes to do its collision checking or whatever. Because we just want it to be the very tip point. So, left 0, right 1, top 0, bottom 1. Just a teeny tiny single pixel for clicking on stuff. Green check out of there, and there. Great. We need one more sprite though. What we're going to do right now is just create another sprite. I'm going to call this S-selected. Edit sprite. New sprite, 32 by 32 is perfect. Let's get in here, and let's just grab ourselves a yellow and our line tool, and we're going to go all the way around the edge twice, because we want our border to be nice and bold, so we want it to be too deep. Just like that. Okay, now green check out of here. We're going to copy this, and we're going to paste it 3 more times, total of 4 images again. This time we're going to go to our second image, image 1, because it starts at 0, and try to make the best orange you can muster out of this little silly color palette here. I want a good bright orange. Let's go with that. And we're going to set our opacity to somewhere around 70, close enough. Get our fill bucket and fill once, then go to the next sprite, or next image, fill twice, and then go to the last image and fill 1, 2, 3 times. Green check out of here. And what we're left with, as you can see in this preview, is this nice little square that sort of flashes from yellow to orange. What we're going to do with this is we're going to have it drawn on top of whichever node the cursor's currently hovering over, so that, like, oh, well, this is the node that we're currently selecting. Great. Green check out of here. Origin's fine. Don't got to mess with the mask. It's just perfect just the way it is, so green check out of there too. Okay, now it's time to make our cursor object. So, create object, call it O-cursor, give it the appropriate sprite, S-cursor, and let's set its depth to like -3 for now. I mean, we're going to change this later. The depths and layers of things are going to matter eventually. For now, we just kind of want it vaguely on top of everything, and that's fine. We'll add an event, create event, drag in a block of code, and let's do some code. Okay, so grid X equals 0, grid Y equals 0, and hover node equals no one. Okay, so grid X and grid Y, they're there to keep track of where the cursor is in relation to that map array we made last episode. Hover node is going to hold on to the ID of whichever node the cursor is currently positioned over. And no one is a keyword, and it essentially acts like null, right? I like to use it when the code expects to find itself an ID, because then I think, oh, well, it's expecting to find an ID here. It's important to be able to read your code easily at like a month after you've written it. So anyway, it also returns -1, and you can use that to your advantage in some places. That's it for our create event. There's going to be a lot more in here eventually, I think, but for now, super simple, right? Now it's time for our first step event, which is interesting. We're 2 videos in, and this is our first step event, but that's just how it works. So, the first thing we need to do is update our cursor's position. So, X equals mouse_X, Y equals mouse_Y. Mouse_X and mouse_Y, they keep track of the position in X and Y of where the actual Windows mouse cursor is, or Mac if you're on a Mac, or I suppose Linux. Are we doing Linux? I don't know. Anyway, so this will just update this object's position to be wherever the cursor for your operating system proper is, and especially within the game window. Okay, so that's fine. That's great. Now we need to figure out where our cursor is in relation to our map array and all of those node objects that we just made. So we'll do that with grid x equals floor x divided by grid size, and grid y equals floor y divided by, that's not a shift, grid size. It's earlier than I normally record. I'm just having the worst time with my poor fingers. They're not cooperating at all. Okay, so all floor does, just real quick, is that it just chops off whatever's after a decimal. Just gets rid of it entirely. So if this returned like 3.17, blah, blah, it'd be whatever, 3, done, easy. So now we need to go about updating our hover node information. And like I mentioned earlier, that's going to be whichever node our cursor's hovering over. So first we need to put in a bit of input validation, because it's possible, especially people running on full screen, if they try to go off their screen to like the left or the right, wherever their second monitor is, it could throw an error because the cursor's trying to find information way over on the other screen, and that's obviously way out of bounds of our map array. So we need to be able to have it only update the hover node information if it's within bounds. So if grid x is less than 0, or grid y is less than 0. Like I said earlier, or works as a keyword if you can't find this silly icon on your keyboard. So or grid x is greater than or equal to room width divided by grid size, or grid y is greater than or equal to room width, room height divided by grid size. I almost had myself an error. Honestly, if I were to build a game from the ground up just to be easy to program, like in hindsight, I should have made our grid perfectly square, because then like we could just have room size or whatever that thing was in the other thing, the map size, rather than dealing with this silly stuff all the time. So, all right. So if all that's true, we're in bounds. And if we're in bounds, oh no, if any of that is true, then we're out of bounds. I'm confusing myself. So if we're out of bounds, hover node equals no one. Easy, right? Else, so if all of that is false, then we're in bounds, and then hover node equals map grid x grid y. Great. All right, now we'll leave this here for now. This is good. This should be good. Let's double check it. So if we're less than 0 on either of these, and if we're greater than room width divided by grid size, and if our y is greater than room height divided by grid size. Why does this look wrong to me? This should be... Whoa. Don't do that. I didn't even know what I pressed to do that. Room underscore width divided by grid size, right? And this should be room underscore height divided by grid size. Right? That looks right, doesn't it? That's got to be right. We're going to go with that. Okay. Hover node equals no one if any of that is true. If all of that is false, then we have a hover node. Green check out of here. And now, finally, we're going to do a draw event. And this one's going to get a little weird. Just a heads up. So, first thing we're going to do in here is if hover node doesn't equal no one, draw sprite s selected -1 grid x times grid size grid y times grid size. How did I manage that? Grid size. There we go. Okay, so what this expects is a sprite, obviously. This is whichever sum image you want it to draw. If you set it at -1, then this will animate on the same schedule as whatever object you're making is. And I'll explain that a bit in just a second. And then it wants a X and Y coordinate. And obviously that'll draw it right where we want it, but this isn't proper spacing to make it look to the rest of the style that I'm doing things in, so I'm changing that. Now we want it to draw itself. Okay, so this is why we have a cursor that has 4 identical subimages in it, right? Now, while it's animating through those 4 identical images, it'll animate whatever else you want it to draw on the same schedule. In this case, it'll animate the selection box on top of the grid we're hovering over. Now, there's a bunch of ways you could have done this. You could have set up some sort of internal step count for the animation, or you could even create another object for the selected sprite, just have it sort of move around. But I think this is super easy, and as far as efficiency is concerned, adding 3 extra sprite images to our cursor is about as low impact as it gets. If it's stupid but it works, then it isn't stupid, right? And really, you could give the cursor the same pulsing animation you gave the selector if you wanted to make it fancy, or maybe like cycling between bright and dark red or whatever. We're going to do one more thing while we're in here. So let's have the cursor show us the grid coordinate of the node that we're hovering over, and we'll draw it just in the top left corner of our room. That way it's just one more thing we can mouse over and make sure everything's working right. So what we're going to do here is if hover node doesn't equal no one, and, well, 2 things real quick. So first off, as I mentioned earlier, no one returns -1. And since instance IDs are always numbers, there's something like 100015 or something silly like that. We could hypothetically do if hover node is greater than 0, because then, okay, well, we know it must be an instance ID, and if it's no one, it'll be less than 0. So there you go. You could do that. But I like doing doesn't equal no one. It's a bit sloppier. It's not as neat looking or cool for all them cool programming guys who like to make their code look fancy. But you know what? In a month's time, I'll be able to read this. I'll look at this and be like, all right, I know what this is trying to do. And that's super important. So the other thing we need to talk about is what's up with this? We've got if hover node doesn't equal no one up here, if hover node doesn't equal no one down here. Why are we doing this? Why don't we just put them in the same thing? Well, that's simple. Why we're doing these similar if statements here and doing everything in this order is because a draw event runs top to bottom and will layer the sprites over the top of one another as it goes. So, top to bottom, we want this to draw the selected sprite. And then we want to draw our cursor on top of that. And then we want this on top of everything else because it's just important information in the top left of our screen. So, that's why we're doing it like this. What we're going to do here is we're going to draw a nice black rectangle with some white text. And all it's going to do is say, let's see, temp text equals string. Whoa, let's do another space there. String grid X plus quotes space slash space quotes plus string grid Y. Okay, so string, all it does is it turns numbers into letters so that it can be stored in a string or be displayed as a string or whatever. So we're taking our grid X and we're taking our grid Y, and then you can add to strings by just using the plus symbol and then quotes. So it's going to be, let's say it's 3 plus space slash space plus 4, and that's what I'll display in the top left corner. Easy. I talked way too much about that. That's really not that complicated. You guys are sharp. So now we want a black rectangle. So draw set color C_black. Draw rectangle 0 0 string width temp text string height temp text. And then that's not done yet. We also need a false. Okay, so these are just X and Y coordinates. So 0, 0. String width returns the width in pixels of a string. It's really handy. String height returns the height in pixels of a string. So we're going from 0 to however long our string is. And then from 0 to however high our text is. And then the last thing we put in here is an outline, right? We want false. We don't want an outline. We want a full, filled-in rectangle. If you just wanted an outline, you could do true there. And then draw set color C underscore white, and then draw text 0, 0, temp text. Great. Real quick, let's talk about this draw text or draw set color stuff because that's important. So, when you do draw set color, you're not setting the color for this object. You're setting the color for all objects. So if you, well, the default is C underscore white. That's what it comes straight out the box. And that's what makes all of our sprites look like they look up here. So if you ever set draw set color away from white for some reason, do whatever it is you need to do and then set it back to white when you're done. Otherwise, it'll draw every sprite if I forgot this, if I didn't have that there, it would draw every sprite with a black tinge, and that would actually probably make our whole screen black because we got a lot of white going on here. So there you go. Always set it back to C underscore white. Coincidentally, we wanted to set it back to white anyway, but it's worth talking about. So now the last thing we need to do is we need to create our cursor. So green check out of here, and we could just throw a copy of it in the room, but I don't like doing that, right? Our cursor is sort of married to our game object because it relies on a lot of information that game's creating. So we can't have our cursor trying to figure out what's in the map array before the map arrays are created. We can't have it try to figure out any of that sort of stuff, right? That would break it. So what we need to do is we're going to create it once it's done with all of that. That way we can be sure it doesn't throw any errors. So right here at the bottom of our game's create event, we want instance create mouse underscore x, mouse underscore y, o cursor. Actually, you know what? It doesn't matter. To heck with it. X, Y, o cursor. I'm pretty sure it won't, because I mean, hypothetically, if we tried to create it outside the room, like let's say you told the game to run and you put your mouse on your second monitor, I don't think that would throw an error, but it doesn't matter where we create it, because the very first step, it's going to update itself to wherever the mouse is anyway. So to heck with it, put it wherever you want, it doesn't matter. All right. So now, the last thing we need to do is we want to hide the default cursor while we're moused over our game window. So green check out of here and here. We want to go to global game settings, this little bit down here. And then we're going to go to Windows, and then yeah, this display cursor thing, get rid of it. Green check out of here. And finally, we know our node objects have their neighbors sorted, right? We watched that. We checked it, we verified that everything's working, so there's really no reason to have that draw event. So let's go into our node, and let's just completely delete this draw event altogether. Gone. Like I said earlier, if it doesn't have a draw event, it'll draw this sprite when it comes time to draw things anyway, so we don't need it anymore. It's done. Green check out of here. Let's fire up our game and see what we got. There we go. Great. So there's our grid. That's working fine. You can see our little flashy cursor looking great, and we can verify that's definitely 0, 0. How wide is my game map right now? Looks like it's 31 wide and 23 tall. Okay, great. So, point is, you should be able to mouse around a bit, and you should see the numbers change in the top left corner, and it'll show 0 for the left and top edges. That's right. If you've got all this working, then we're ready to add a character or two in the next video. I'm going to beg for internet points again. If you're enjoying the tutorial series, be sure to like or subscribe, and you can follow me on Twitter at Sergeant Indy. Feel free to leave a comment below if you're lost or something broke. I'm more than happy to help you out. Thanks for watching, everybody. I'll see you next time.